Sir, recording started. Recording. So today we are going to see the magnetic particle testing. So in the previous video, we have seen about the introduction to non-destructive testing or non-destructive examination. So in this video, we will see the details about magnetic particle testing. Magnetic particle testing. Okay. So this module is intended to present information on the widely used method of magnetic particle inspection. Magnetic particle inspection can detect both production discontinuities and in-service damage. So magnetic particle inspection method is an NDT method. So it can both detect both production discontinuities and in-service damage. So what are all the production discontinuities? Seams, laps, grinding cracks, and quenching cracks. All these are production discontinuities. And fatigue and overload cracks are in-service damage. So the defects produced during production or manufacturing are known as production discontinuities, and the defects produced during the service of the component is in-service damage. So in this video, we are going to see about the magnetism and ferromagnetic materials, introduction of magnetic particle inspection, basic procedure and important considerations like component pre-cleaning, introduction of magnetic field, application of magnetic media, interpretation of magnetic particle indications, and examples of magnetic particle inspection indications. Okay, so first of all, you'll see about the introduction to magnetism. Introduction to magnetism. So magnetism is the ability of the matter to attract other matter to itself. So magnetism means the ability to attract other matter to itself. So objects that possess the property of magnetism are said to be magnetic or magnetized, and magnetic lines of force can be found in and around the objects. So magnetic lines of force will be produced in materials which are magnetized. So a magnetic pole is a point where a magnetic line of force exits or enters a material. So a magnetic pole is nothing but a point where a magnetic line of force exits or enters a material. Okay. So next one is magnetic field lines. So what are the magnetic field lines? Magnetic field lines are found in material which are magnetized. So magnetic field lines form complete loops. Magnetic field form complete loops. Magnetic fields do not cross and follow the path of least resistance. Magnetic field lines have the same strength, all have the same strength, and have a direction such that they cause poles to attract or repel. So they have a direction such that they cause poles to attract or repel. So as seen shown in the diagram, first diagram shows the magnetic lines of force around a bar magnet. Second diagram shows the opposite poles attracting. Second diagram shows opposite poles attracting, and the third diagram shows similar poles repelling. So in the second diagram, you can see the magnetic lines of force are being attracted. In the third diagram, you can see the magnetic lines of forces are repelling. Okay. So how does magnetic particle inspection work? How does magnetic particle inspection work? So we can carry out the magnetic particle inspection only for ferromagnetic materials. That is the materials which can be magnetized. Those materials can only be subjected to the magnetic particle inspection. So other than the ferromagnetic materials, those materials cannot be tested using this method. Okay, so a ferromagnetic test specimen is first magnetized with a strong magnetic field created by a magnet or special equipment. So we are going to use a special equipment or by other means to first magnetize and form a magnetic field around the test specimen. If the specimen has a discontinuity, the discontinuity will interrupt the magnetic field flowing through the specimen, and a leakage field will occur. And a leakage field will occur. Okay. So as you can see in this diagram, so first the the material is magnetized by using a magnet. So this is the magnet which is kept on top of a specimen, on a test specimen. So the North Pole and South Pole are kept in such a way that the crack is in between the North Pole and South Pole of the magnet. So you can see the test specimen is magnetized, and the magnetic lines of force are as shown in the figure. Magnetic lines of force are as shown in the figure. So the discontinuity will interrupt the magnetic field flowing through the specimen, and a leakage field will occur. So as shown in the second diagram, the magnetic fields are flowing from the south pole to the north pole. So these are all the magnetic field lines. So when it encounters a discontinuity, or a crack, what will happen? there will be an interruption in the magnetic field flowing. The flow will be interrupted. Magnetic lines of flow will be interrupted, and a leakage field or a flux leakage will be developed. Flux leakage will be developed in at the place where there is discontinuity or the crack. So how does the magnetic particle inspection work? So the finely milled iron particles are coated with the dye pigment and are applied to the test specimen. These particles are attracted to leakage fields and will cluster to form an indication directly over the discontinuity. Okay, so this indication can be usually detected under proper lighting conditions. So this is, as the diagram shows, the magnetic lines of force will flow from the south pole to the north pole, as can be seen by the arrow marks shown. Okay, so these are all the magnetic field lines. Now there will be flux leakage because of the presence of the discontinuity or the crack. So we are going to apply finely milled iron particles coated with dye pigment. So dye pigment coated finely milled iron particles are applied on the test specimen. So these particles will get attracted to the leakage field. So as can be seen, the green color shows the dye of the finely milled iron particles. This will be attracted to the leakage field. So after attraction, so we can easily detect using proper lighting condition the flux leakage or the crack. So what is the basic procedure? The basic steps involved are component pre-cleaning, introduction of magnetic field, application of the magnetic media, and then interpretation of the magnetic particle indications. So these are all the basic steps involved in the magnetic particle inspection method. So in the pre-cleaning, when inspecting a test part with the magnetic particle method, it is essential for the particles to have an unimpeded path for migration. Okay, so the part surface should be clean and dry before inspection. So that's the part should be clean and dry. There should not be any unimpeded path for the flux flux in the material. Okay, so the contaminants such as oil, grease, or scale may not only prevent particles from being attracted to leakage, but they may also interfere with the interpretation. So the contaminants, there may be contaminants like oil, grease on the material which we are going to subject to magnetic particle inspection. So the oil and grease particles should be first removed. That is why we are performing the pre-cleaning. Pre-cleaning as the first step. So this will remove the grease or oil or dirts on the material which we are going to inspect. Okay. So next step, introduction of the magnetic field. The required magnetic field can be introduced into a component in a number of different ways. So we are going to introduce the magnetic field in the material which we are going to test. So using a permanent magnet or an electromagnet that contacts the test space. So we are going to use a permanent magnet or a electromagnet for magnetization or flowing an electrical current through the specimen. We are going to flow electrical current through the specimen, or we are going to flow an electric current through a coil of wire around the part or through a central conductor running near the part. So by these three methods, we are going to magnetize the particle which we are going to subject to magnetic particle inspection. Okay, this is the second step. The direction of the magnetic field. So here, this is important. The direction of the magnetic field that we are going to subject is of two types. So one is the longitudinal, the other one is the circular. So the type of magnetic field established is determined by the method used to magnetize the specimen. Okay, so the magnetic field can be longitudinal or it can be circular. A longitudinal magnetic field has magnetic lines of force that run parallel to the long axis. So the longitudinal field lines run parallel to the axis of the specimen, and circular magnetic field run along the circumferential direction of the specimen. Okay, so the magnetic lines run circumferentially around the perimeter of the part. Okay, in the circular magnetic field. So the importance of magnetic field direction. What is the importance? So being able to magnetize the part in two directions is important because the best direct detection of defects occurs when the lines of magnetic force are established at right angles to the longest dimension. So the defects and the line direction between the defect and the line of force, magnetic lines of force, should be 90 degrees. So as you can see in this first diagram, the flux leakage takes place here. So this defect is along the perpendicular direction to the flow of the magnetic flux. So there will be flux leakage. But in this second defect, there will not be any flux leakage because the magnetic line of force and the defect or cracks are in the same direction. They are longitudinal. So here no flux will be detected. So in order to have a good flux leakage, the angle between the crack and the magnetic lines of force should be between 45 degrees to 90 degrees. Only if the angle between them is between 45 degree to 90 degrees, we can easily see the flux leakage. So as you can see here, the circumferential magnetic flux line can detect the longitudinal cracks, and the transverse cracks can be usually seen by magnetic field along uh, the longitudinal direction. Okay, so how to produce a longitudinal magnetic field? So longitudinal magnetic field is established by placing the part near the inside of a coil's annulus. So in the diagram as shown, the coil, the material to be tested is placed near or inside the annulus of the coil. So this is the coil. So here the magnetic field is induced in the material, and this is the current carrying coil. So this is the longitudinal magnetic field. For producing a longitudinal field using permanent or electromagnet. So here the crack is along the this direction. So the electromagnet is placed here in this direction so that the flux will flow from north direction to south pole, north pole to south pole. So this is done by using electromagnets. How to for using circular magnetic field? So in order to induce circular magnetic field, we are going to pass the electric current along the length of the material. So in that case, the magnetic field will be produced along the circular direction. So here, this is the diagram showing the induction of circular magnetic field. Okay. So application of magnetic media. So the magnetic particle inspection can be performed using either dry particle or wet particles. Okay, or particles suspended in a liquid. So the dry method is more portable. The wet method is generally more sensitive. Okay, the wet method is more sensitive. The liquid carrier gives the magnetic particles additional mobility. So that is why we are going to use the wet particle method. Okay, so the particles will be suspended in the liquid, and we can get the easily we can get the see the cracks using the bed method. So we are going for the bed method. So dry magnetic particles are magnetic particles come in a variety of colors. So we have to choose the colors The color that produces a high level of contrast should be selected. Wet magnetic particles. So these are the particles which are which provide visible or fluorescent light. Okay, visible particles are viewed under normal white light, but fluorescent particles are viewed under black light. So after applying the magnetic field, the process requires that the inspector distinguish between relevant and non-relevant indications. So the inspector has to examine and he has to distinguish between the relevant and non-relevant indications. So here, this is the crane hoop which is tested using the magnetic particle inspection method, and we have used the fluorescent wet particle method. So you can see the crack here, the crane hoop. Similarly, a gear with service-induced crack is detected. So here the examination shows the wet particle method. So the fluorescent wet particle method shows the crack in the gear, which is induced due to service. Next, we can see the drive shaft with heat treatment induced cracks. So here also we are using the wet particle method. Next, the spline shaft, which is service induced, and the cracks are seen as shown. Next, a threaded shaft. So here this is the threaded shaft. Here also we can see the crack. So this is a large bolt. The crack induced can be easily seen using the wet particle method. And here is the crankshaft, and the crack induced near the lube hole can be easily seen. So this is the shielded metal arc welding produced part, and here we can see the lack of fusion. Lack of fusion here creates a crack. So this is examined using dry powder method. Similarly, a toe crack in the shielded metal arc welding. This can also be seen using the dry powder method. Throat and toe cracks in a partially ground weld. So this weld has been grounded, and we can see the toe cracks using the dry powder method. So next we go for the demagnetization. So the parts inspected by the magnetic particle method may sometimes have an objectionable residual magnetic field. So the residual magnetic field has to be removed, or it has to be demagnetized, or otherwise it will interfere with the performance of the component in the service. So why we have to go for demagnetization? It may interfere with welding or machining operation. It can affect gauges that are sensitive to magnetic fields. So abrasive particles may also adhere to the components. So in order to avoid all this, we have to go for demagnetization of the component which has been magnetized and which has been subjected to the magnetic particle inspection testing. So the demagnetization requires that the residual magnetic field is reversed and reduced by the inspector. So the residual magnetic field has to be reversed and it has to be reduced. So here this diagram shows the magnetized particle, and here this shows the demagnetized. So the orientation you can see, magnetized material will have the orientation along the south pole to the north pole, while demagnetized material does not have any orientation. So what are the advantages of magnetic particle inspection? It can detect both surface and near subsurface defects. So the defects which are present on the surface and which are present below the surface, that is on the subsurface, can be detected. We can inspect parts with irregular shapes. So irregular shapes can also be subjected to the can be inspected. Pre-cleaning of components is not as critical as it is for some other inspection methods. So pre-cleaning is not a critical step. It is very easy step. So the most contaminants within the floor will not hinder floor detectability. The contaminants will not hinder the detectability of the crack. So fast method of inspection and indicates visible directly on the specimen surface. So this is a fast inspection method and the cracks are easily visible on the specimen surface. It is considered to be low cost compared to many other methods, entity methods. So it is low cost. It's a very portable inspection method, especially when used with battery powered equipment. It's a portable inspection method. So it can be taken from one place to another. So what are the limitations of magnetic particle inspection? It cannot inspect non-ferrous materials such as aluminum, magnesium, or most stainless steel. So most stainless steel and non-ferrous materials like aluminum, magnesium cannot be inspected. Inspection of large parts may require use of equipment with special power requirements. So large uh, inspection components cannot be inspected. It requires equipment with special power requirements. Some parts may require removal of coating or plating to achieve desired inspection sensitivity. So in order to have high sensitivity, the coating on some material should have to be removed or the plating have to be removed to improve the sensitivity. So okay, so the sensitivity can be improved only by removing the coating or plating on some components. Limited subsurface discontinuity detection. So limited surface discontinuity detection. So maximum depth of sensitivity is zero point 0.6 inches. So more than zero point 0.6 inches cannot be detected. Post cleaning and post demagnetization is often necessary. So post cleaning and post demagnetization is necessary. Alignment between magnetic flux and defect is important. So the alignment, the direction between the magnetic flux and defect is important. Okay, so this is the magnetic particle inspection method. Thank you for watching.